I asked Google AI whether there is any advantage for analog multimeter over digital. Analog multimeters are supposed to be better for visualizing rapid changes and providing real-time trends in a more intuitive way. They are less susceptible to electrical noise and can have lower input impedance, which can be beneficial in certain circuits. But this can also cause them to be more easily affected by the circuit being tested. I was using an analog multimeter about 4 decades back because it was all I had at that time. In recent times, till today, I had only a digital multimeter because the old analog multimeter was no longer traceable. A few days back, I noted that the digital multimeter, which is also several years old, was giving wild values while measuring the voltage output of inverters. It could be because it is not a true RMS meter. A friend told me that in this situation, an analog multimeter may be better, and I wanted to try it out. It has been mentioned that some analog multimeters have a higher output voltage in the resistance testing mode, like 10.5 volt or 12 volt, compared to the low output of digital multimeters of around 1 volt, which could be advantageous for testing thyristors and light emitting diodes. This is the new analog multimeter which I purchased from a local electronics spare shop. It needs a 9 volt battery as well as a couple of 1.5 volt batteries, which have been provided along with the test probes in this package. Digital multimeters are likely to be more accurate and free from parallax and reading errors, which can occur with analog multimeters. Digital multimeters have a wider range of functions like capacitance, frequency and temperature measurements, which analog meters do not have. With lesser moving parts, digital multimeters can be more durable. This multimeter has a cover with a stand which can be used to keep it in a slanting position. The tray can be taken out and replaced quite easily. A star-edged screwdriver can be used to remove the back cover to install the battery supplied along with the device. After removing the back cover, rear side of the printed circuit board can be seen. Slots for mounting 9 volt battery and a couple of 1.5 volt batteries can be seen. Being a new device, I did not try pulling out the PCB to see the components mounted on the other side. Fix the batteries which came with the device in the corresponding slots, taking care of the polarity. Move the selector switch to buzzer mode to check continuity by buzzer sound. You can hear the buzzer sound when the multimeter probes are being shorted. Another way of checking continuity is by selecting the into 1 in the ohms range, which has also been labeled as continuity in red color. There is a red light emitting diode in the top left corner of the meter, which glows when continuity is being checked by shorting the multimeter probes. As there is no resistance involved during this test, the multimeter needle shows a full scale deflection. This is one of the pages of the instruction manual provided, showing the parts. Optional accessory for testing HFE or beta of bipolar junction transistor is not there in the package. HFE stands for Hybrid Parameter Forward Current Gain Common Emitter. My previous digital multimeter had slots for mounting NPN and PNP transistors to test HFE, which I had demonstrated earlier. Here is a still image showing the various ranges for selection, batteries provided, and the test probes taken prior to installation. The LED for continuity checking can be seen at the top left corner. Blue scale below that is for display of resistance values. Just below that is the scale for AC and DC voltage and current. A chart has been provided to know which row has to be used to read each range of the measurement selected. Below that there is AC 10 voltage range in red color. Still below that the scale for HFE is shown in blue, ranging from 0 to 1000. That provides the ratio of collector current to base current in common emitter configuration for bipolar junction transistors. Next row is for ICEO in red color. ICEO is the current that flows from the collector to the emitter of a bipolar junction transistor when the base is left open, unconnected. It is a measure of the reverse leakage current of the collector emitter junction. High ICO leakage can indicate a faulty component. According to the manual, if the pointer is not within the leak zone and moves near to the full scale, the transistor tested is not good. For testing NPN transistor, the N terminal of the tester is connected to the collector of the transistor and P terminal to the emitter. Reverse order is used for PNP transistors. The last row in the meter is the decibel meter. Decibel scale is used to measure the ratio of AC voltage levels and not sound intensity. Note that the multimeter does not have a sensor like a microphone to capture sound waves like a sound level meter. Decibel meter is an almost exclusive feature of analog multimeters, though some advanced digital multimeters may also have it. Decibel meter is useful for measuring audio signal levels and radio frequency signal levels. Decibel is a logarithmic scale and the comparison is with a reference voltage which could be 1 volt or 0.775 volt depending on the setting in the meter. Hoping to use this analog multimeter to the maximum extent possible in my various hobby projects.